well, thank you for that introduction, Dr. Gupta. It is great to be back on campus. I know most of the people in the room are new faces to me. I see a few familiar faces for when I used to be at the University of Minnesota here, some of which I've certainly continued to bump into over the years at different times. So glad to see everyone. Thanks to you for joining today. For the online audience, Dr. Cates is kind enough to be monitoring the chat. My setup up here isn't going to allow me to get to the questions if anyone has comments, so she will interrupt for you if you're online and want to chime in. As I get into things, happy to take questions at any point during the presentation. If you guys just let me talk the whole time, I'm guessing I'll get done around the 40-minute mark, so should still be plenty of time for questions and discussion at the end as well. As my title implies, I tried to frame this in a way that focuses not only on the project work I get involved in at Houston Engineering, but trying to offer a little bit of perspective as to what it's like to be a consultant working on environmental outcomes, kind of an implied science space rather than a primary research space. So if you attend these seminars regularly, what I remember from them, and it has been a few years, is you're usually getting a pretty deep dive into a focused research topic. Today's going to be a little different because it's going to be more of a survey of case studies, giving you a flavor of what it's like to be engaged in consulting in this space around the topic that my title is focused on. So just a quick background on Houston Engineering, in case you haven't heard of us. This is not meant to be a sales pitch about our company, but just to give you a sense of who the firm is. First off, you hear Houston Engineering, you might think of Texas. We have no affiliation with Texas whatsoever, other than we have done some project work down there. Our founder, like many great founders do, named the company after himself. His name was George Houston. We've been around for over 50 years. We have over 250 employees. And the dark green dots on my screen are our physical office locations. The light green on the screen is indicative of the areas where we've had some form of project in the continental US. I was the one who got to have this project. It is one of my favorites. They brought me on site 2 times for the project, which was fantastic. So you get to go on some adventures every now and then in consulting, a lot of fun. I would say, though, just to be fair, the bulk of what we do as a firm is centered around where those geographic footprints are. Give me a minute. I'm going to try to drag this down so it doesn't pop up in front of us. Is that a little better for doing? Perfect. What I'm going to focus on today, though, is only a part of what our firm does, and it's really connected to the sector within the firm that I work within. So you see the banner up top, and that lists the various sectors we have. Those are kind of the areas of expertise within our firm. I'm positioned within the firm's environmental sector, and then within sectors, we have what we call practice groups. So that's a further refinement of the expertise within the sector. And I'm going to be talking about some of the work, and I highlighted in yellow, so it's hopefully easy to see, although the text is very small. I'm sure if you sit in the back of the room, our sustainability and climate practice group. Oh, no, it doesn't want to move for me. Here we go. And in particular, we offer a range of services in this group, but I'm going to focus on some case studies of projects that we do connected to agriculture, with an emphasis on greenhouse gas assessments around water, and then some of the technical work we do, I call it applied science connected to policy. So we get involved with clients where maybe there's a policy issue and they need applied science to kind of help them navigate it. So I'm going to go over a series of case studies as we get into this. The emphasis is actually going to be on estimating greenhouse gas outcomes. And a bit of an oddball thing for me to be here presenting because I had no educational background in it. But it is kind of why I picked it, because it fits the nature of consulting, at least in my opinion, where we do have some focused expertise usually when we get involved, but we got to adapt a lot while we're doing our work to serve the needs of our clients. So they got a problem, we need to try to solve it for them. And over the course of these case studies that I'm going to start going through, that's what I'm hoping I'm able to highlight for you, is a flavor of the types of problems that we get to solve through applied science in consulting, and with the emphasis of the talk being on challenges facing agriculture. And I know I'm preaching to the choir for many in the room here. I think most people would recognize that we need more food, but the expectation of society in general is that we're able to produce that food with fewer environmental impacts or even improved environmental outcomes while we're producing that food. So again, the first series of case studies is going to be on greenhouse gas. Now, when I use that word in the Department of Climate, Soil, Water, and Climate, I'm sure that term can mean a lot of different things to a lot of different people. But in general, the work we get involved in is estimating how emissions are occurring during the production of food, fuel, and or fiber. Typically in our firm, we focus more on the food and fuel end of that space. We don't get involved a lot in work that's focused on fiber. But in general, within supply chains, there is a pretty strong interest in reducing the greenhouse gas footprint for the production of food. So a few years ago, we started having clients come to us and ask us, hey, could you help us figure this out? And that's where we got involved. So one of the first, what I'm calling case studies here, was a project that we took on for Minnesota Soybean Research and Promotion Council. You'll see I'm going to highlight several projects that we've been involved in with Minnesota Soybean Research and Promotion Council, along with a few other clients. But this was about 4 or 5 years ago. Some of you may remember some information in the news where Microsoft was in Minnesota and other places offering money to buy carbon credits in agricultural lands. And at that time, Minnesota Soybean Research and Promotion Council approached us because they had a few folks within their group, some of their farmers, saying, well, we don't want to lose all of our carbon and sell it to Microsoft across the state. Could we just offset that ourselves? You know, not having a lot of context for what that might mean or what the scale of the problem could be. So we got approached, and this was one of our first efforts getting into greenhouse gas assessments, to say, hey, Houston Engineering, we're used to doing some projects with you. We're not looking for a full research study on this, but could you look at the literature and give us a sense of what the emissions might be for producing soybeans in the state of Minnesota, and what our opportunities could be to offset that? And then as things progress, we added some things onto that through a series of reports, where we also started to look at some of the products that can be derived from soybeans, things like biodiesel, tires, glycerin, feed, and trying to come up with some at least statewide estimates as to what those footprints might look like and the opportunities to either reduce or offset those footprints. So I'm not going to do a super deep dive on methods in any of these case studies, but giving you a sense of how we performed the analysis, we did what was similar to a life cycle analysis for soybean production in the state of Minnesota, and basically mined a lot of data from the USDA in terms of production statistics across the state, how farming was done, and then used a lot of literature values for what the associated emissions would be with those various production practices. And when I show you some of the information on biofuels, we use the simplified version of the GREET model. If you any familiarity with the biofuels industry, if you produce fuel and need to understand how much carbon you're emitting associated with the fuel, you become very familiar with GREET, because that's the tool they tell you have to use. So this is what some of our initial results look like when we did this work. And what we are estimating was that per hectare of soybean production, you're emitting over 3,700 kilograms of CO2. So when you take that across the state, it's a pretty big number. That's probably not all that surprising if you think about it. We know agricultural production emits greenhouse gases. But the question they really wanted to get at then is, well, could we just eliminate that on our own? Do we have to sell carbon credits to Microsoft, or could we maybe blunt that and other efforts that might be interested in, taking any reductions that could occur? And so we looked at some of the common conservation practices that could be implemented on agricultural acres. Now, fair disclaimer here, when we generated this number in the next box, we had no knowledge as to what conservation was actually out there on the landscape, right? This was a high-level, theoretical, what could this look like type of a study. And so we looked at the total potential to reduce carbon on acres. And our answer was, you could maybe reduce that footprint by about 2,350 kilograms of CO2e per hectare of production. Now, that's an average. And if you go into the report, there's huge plus or minus bars on these numbers, because this is a very broad scale empirical study. And then we also asked the question, well, if you wanted to reduce this yourself and you looked across the globe, is there big enough carbon pools you could think of to start to take a chunk out of that on a per hectare basis? And if you want to go and start restoring forests, you might be able to make some progress. That was the gist of it, and that's where that 5,000 number comes from. And then we went on to get into some of the associated products and their emissions. And I'll build a story a little bit between the case studies and how some of this work starts to build together as we get into the expertise we built through the work. But they're interested in the emissions of biodiesel. So we also generated estimates for that, as well as some of the consumer products. We just labeled them that way. You might want to label them a different way. associated with soybean production and came up with estimates for those as well too. And then the final thing they're interested in this work is how would B20 mandated blend in terms of the emissions per year compare with the conventional diesel product? You know, in general, I'm sure soybean production was interested in finding out if their footprint was smaller than conventional diesel production. And at least with the way we set up this study for Minnesota soybean production, it did indicate that blended biodiesel had a slightly lower carbon intensity than petroleum-based diesel production. So the next study I'm jumping into was done for Clean Fuels Alliance America. They came to us with a somewhat related project focused mainly on the use of Argonne's GREET model. But what they were struggling with wasn't really on the soybean production end and the footprint, but they were struggling with communication between the groups that produce fuel, so fuel producers, and those that purchase the fuel. And what's really important in the industry right now, and some of you may be well aware of this, is when you produce a biofuel, that carbon intensity score becomes pretty important for market access, for now tax credits and a variety of other purposes. And they wanted an easier system for fuel producers to be able to generate their carbon intensity score for their fuel and have that as a communication piece with the consumer who's going to purchase the fuel from the entity producing it. So we got a contract to develop a customized tool on behalf of Clean Fuels Alliance America that would make this a little bit easier on a nationwide basis for a fuel producer to enter information on how they produce the fuel and have it get segmented out into different carbon intensity scores so that the purchaser of that fuel could understand the footprint associated with it. Now, we did have to limit the scope of this a little bit. We couldn't say we will do it for every type of renewable fuel on the planet. Would have gotten a little too big and unwieldy. So the different systems we developed this informational piece for were for biodiesel, renewable diesel, and sustainable aviation fuel. I'm sure if you watch the news at all in this space, sustainable aviation fuel is getting a lot of buzz with Delta and some other organizations, a lot of interest in producing it and producing it with a very small carbon footprint. And the gist of what we produce, just as an example, is shown on the screen here. So it's an Excel-based tool that is based upon Argonne's GREET system. So we kind of broke those apart, put it together, and repackaged it in an easier to use information system. And so this looks like a lot of data points. If you're just looking at it at the screen, I bet if you're in the audience, you probably can't see any of this that I have up here on this. I'm seeing Carl saying, yeah, Drew, I can't read any of that. Wasn't the intent to show you all these data points, but give you a sample of the type of inputs. And this is actually a very simplified version of the tool compared to what's inside a GREET if you got to do that manually. But it is things that fuel producers would commonly have for doing these calculations. So this piece really isn't all that hard for the fuel producer to come up with. They have this data. And GREET is a known calculator. You put the data in, it runs the calculations, you get your numbers out. The difficult piece and the problem we're really trying to solve for our clients is how do we make this as easy as possible? And this is reduced. And then how do we spit out something that the fuel producer can use to communicate to the person who's purchasing it? And that's this figure on the right here, where it breaks down the carbon intensity of the score into the different components in which are important to those corporate entities that have to count for those carbon intensities when they're looking at their corporate footprint. And so really hard to see here on the screen, I apologize, but these colored boxes do correspond to different components of the fuel production. So yellow up top is fuel use. The very dark blue thin line is fuel for transportation. And the fuel production is this broader turquoise box. The feedstock transportation is here, and then feedstock itself is this lighter teal color. Now, if you're not familiar with the jargon associated with the fuel industry, feedstock means the prompt, basically, that was used in the production of that biofuel. So maybe not too surprising to see if you're familiar with the space that the biggest part of that footprint is still that feedstock production. And that varies a lot depending upon what type of feedstock is going into the biofuel. For the example I have here, this is soybean oil. There are several other feedstocks that can be used in biodiesel production. And just as a point of clarity, this is made up values in here. We call it ABC fuels. So I'm not disclosing any information from a fuel producer that I'm not supposed to. Now, kind of tying these together, the first thing I went over in terms of a case study was estimating the emissions footprint of soybean production in the state of Minnesota. The next thing I transitioned to was, well, what does this look like if you are a biofuel producer in terms of some informational pieces that could help you in the communication around the carbon intensity outputs of your production? We were interested in kind of backing up a little bit. And if you know anything about the GREET model and you are using it to do a calculation on the carbon intensity of fuel, it gives you a lookup value for your feedstock. So that really big bar that I showed you is predetermined when you click on a box, click on a drop down, and you click on, I use soybean oil. It doesn't really take into account the manner in which that soybean oil was produced, whether it's from the field to the fuel producer's plant. So it's a fixed score. We were thinking about that and, understanding the context of agriculture and how much variation there is, even within the state of Minnesota and how soybeans are produced. We're like, I bet there could be a little more to that story. I would bet if these calculators recognized variation in production practices, there would be opportunities for that score to be lower. And these types of themes are emerging in the industry right now as it is. Some of you have maybe heard of the 45Z tax credit that's been discussed recently. If you follow kind of policy and politics connected to biofuels, that tax credit is kind of one of the first that would recognize changes in the carbon intensity of the production feedstocks. So when we finished this up, it was a little timely in terms of potential information for the state of Minnesota. I don't think it's been used a lot yet, but it was an interesting project to jump into. The basis of which was we wanted to take a look at what a typical farm would look like in different regions of the state, estimate the carbon intensity of the production of soybeans on that farm, and how production practices on that farm might influence a final carbon intensity score on a fuel if that soybean was used to produce a fuel. So I'll walk through that in the next couple of slides and kind of what the results look like. So I did just highlight these methods briefly on the previous slide. We broke the state up into different regions. You'll see as I get into this, we did not do anything with the north central region and the northeast region. If you're not familiar with Minnesota, there's not many soybeans up there. It's mainly just trees and lakes. And we used a multi-model ensemble approach to try to figure out what would a typical carbon intensity score look like for soybean production in the various agricultural regions of the state. And when I say a typical farm, what we did is we went to the FinBin system, which is actually, I think, owned and operated by the University of Minnesota, if I remember correctly, as well as NASS statistics to come up with what the typical production practices would be for a farm on each of these regions. And when we finished this report, we stuck each one of those farms as an appendice in the back. So if people don't like our results, they can go take them out, change the values of the farm, come up with their own numbers. But the gist of it was we weren't using an individual farm. We were trying to come up with a farm that was representative of each of these regions. We then used a combination of modeling approaches to try to understand what's the carbon intensity of that soybean production and how does that translate into the carbon intensity of the fuel production. And so this is what the results look like. Again, Carl, I apologize, back in the room, you might not be able to see this very well. I can explain it a little bit. What you see on the x-axis here, and we're calling this the base condition for each region, so that would be the standard farm. What would the carbon intensity score of soybean production look like on that farm run through these models? The letters on the x-axis correspond to an abbreviation of the agricultural region. These dots then correspond to our estimate of the carbon intensity score of producing that soybean in kilograms of CO2e per bushel of soybean for that region. As you can see, most of these calculators, which are pretty empirical in nature, come in pretty close. The DNDC model gave us a lot more variation and made all of our averages jump all over the place. But in general, there wasn't a lot of variation across the state when you were looking at the median scores. There were some pockets where those standard production practices we came up with did have a lower CI score as compared to some neighboring that were higher. This wasn't the main result we were looking for. Generating a CI score on a soybean crop isn't the most novel thing in the world. There's lots of ways to do it. But what we were interested in is when looking at standard production practices, if we added in new conservation, how much could that CI score be driven down? And that's what I'm showing on here. So same models, same agricultural regions. the potential ranges and reduction in that carbon intensity on those standard farms. And then finally, the thing we're most interested in, so now if we take this, we take a soybean crop from that region, standard production, we reduce the CI score, and we bring it into GREET, not using the lookup value that it tells you to use, but our adjusted value that's more representative of production in that region. What type of changes could you expect in the actual carbon intensity of the fuel that comes out of that plant? Because that's where the impact starts to occur in terms of that product. And I didn't show the results from the individual regions here, but more the punchline of where things could end up. And what we found from doing this is a 1 kilogram of CO2e reduction in bushel of soybean would end up reducing the CI score of your biodiesel by 0.91 grams per megajoule production. So these numbers seem really small, just taken as a punchline, but when you put this into huge volumes of fuel, it's a potential substantial change in the carbon intensity of that fuel. And if you take that into something like a tax credit now that can save that fuel producer a lot of money, starts to become some financial incentives to start to think about conservation and changes, not just at fuel production stages, but in how the feedstock was growing coming into that plant. Another way to think about that, so every 10% reduction in soybean CI is about a 1.42% reduction in biodiesel CI. So big shifting gears here. First couple of case studies I went through were focused on soybean. We're shifting gears to dairy now. So again, I intentionally set it up this way so you start to get the flavor of what it's like to be in consulting as I work through this presentation. We shift gears a lot. We get to do a lot of fun projects. We focus on a variety of things. But, you know, when we have people come into our shop that have been in academia for a while, we say, you know, in academia, you get a lot of time to focus on things. If you're publishing a research publication, you might get to version 30, 40, 50 before it's finally done. We get about V3 in consulting, and then we're done and we're moving on to the next project. So I think you might feel like that when we get out of the seminar today with a variety of case studies I'm going through and some of the shifts in the focus. But I did that intentionally to give you a sense of what consulting is like in this space. So over the last several years, we've been fortunate enough to get to work with a nonprofit called Farmers for Sustainable Food. They're located in Green Bay, Wisconsin, but they are a sister nonprofit organization to Edge Dairy Farmer Cooperative. Edge Dairy Farmer Cooperative is the third largest by volume of milk dairy farmer cooperative in the nation. So they actually represent more milk than like a Land O'Lakes. And they have an 11-state footprint, so they got a really big farm footprint they serve in terms of their cooperative. And several years ago, they spun off this 501c3 nonprofit called Farmers for Sustainable Food. And I'm going to get into some of our project work that we've done for them, but a little bit of backstory to Farmers for Sustainable Food and how they got going in this space, you know, going from a dairy cooperative to a group that I'm going to demonstrate in just a little bit here on the next couple of slides that's taking on focused sustainability projects with applied science. Wisconsin's actually got a really unique state-led program focused on forming farmer-led groups. At least I think it's really unique. So their state, through general funding, has created a dedicated pot of money on an annual basis that groups of farmers can come together, form a group, and apply for grant funding to really be the leaders in how sustainability and conservation are occurring within their geographies. So I want to say there's something like 30 plus farmer-led groups that are organized geographically across the state of Wisconsin. If you can see my map, I mean, it represents pretty much all the agricultural regions of the state. They have a map online. DATCAP is the name of the state agency that administers those funds. And really kind of a unique program relative to how groups of farmers are trying to be rallied in certain parts of the state to get involved in nation to get involved in sustainability and conservation. And that's where this group, circling back to what I have on the slide, Farmers for Sustainable Food, was formed. So they were formed as a nonprofit that could assist in the administration and operation of these farmer-led groups. Because, I mean, you think about this for a minute. Group of farmers come together and get handed state money. They need some structure to administer that money and carry out the program. Farmers for Sustainable Food was a solution for that. And they don't work with all the farmer-led groups in Wisconsin, and you're not going to really be able to see this very well in the room. But here's the icons of the 8 or so different farmer-led groups they've been serving already when we had the chance to get to know them. We got brought in as a consultant and this is kind of my purpose for the backstory, because as these groups had formed and started to get these consistent injections of annual funds, they started to ask the questions of, well, we're here, we're formed, we're operating, we're functioning pretty well. What if we want to take on projects that do a little more than just this state-based grant that we've been receiving on an annual basis? So we came in and assisted Farmers for Sustainable Food and the Nature Conservancy to set up a framework for, consistent with Farmers for Sustainable Foods model, how they could set up and establish farmer-level sustainability projects. And really all it did was laid out some high-level guidance for if you were to like write a scope for a project or a study, how would you do that consistent with farm leadership in the model that Farmers for Sustainable Food put together. And all that long-winded background to say, to lead into the project example, is through this framework, they then went out and got a USDA Climate Smart Award. People heard that term before, USDA Climate Smart. So they got one of those awards. It was a $50 million project through this framework that they're able to implement across their footprint. So it wasn't small. And Edge Dairy Farmer Cooperative, their sister private organization, was the lead applicant. Farmers for Sustainable Food was a subrecipient of the award that was responsible for working with the farmer-led groups across their footprint to try to enroll over 300 farms to engage in this project consistent with their framework. It's a little bit of a long backstory, but to set up why we're working with dairy in Wisconsin, this was kind of the pathway that we got involved. And really the focus of that project was to get farms, these 300 farms, enrolled and give them a very comprehensive baseline on how they were impacting the environment based upon their current operations. The hope was then, and this is kind of the model of Farmers for Sustainable Food, not to come in and try to sell them cover crops or tillage or some of the different conservation practices, but to show them their baselines, allow them to interact as a community, and allow them to make the decision on what's going to fit best for making their scores better. So for any of you that have worked with farmers in the room, I think you know that if you show them their score and they're aware of their neighbor's score, they want to make their score better. And time and time again, that's proved true for the work that we do in general. And so our role in this, the purpose of the project was to use this USDA money, and it wasn't all 50 million. They had other partners at the table. They were working with the sugar beet industry and some other nonprofits. So when it came to Farmers for Sustainable Food, they had a chunk of that money to get to work with these groups. And they wanted to pay the farmer for their time, because when you do these comprehensive baselines, I'll get to the methods in a minute, it's over 250 data points on a farm in their annual operation that they have to give you so you can do these assessments. So it's a pretty long meeting for that farmer to talk about data points for sustainability calculations. They wanted to be able to work with over 300 farms over the course of 5 years on a consistent annual basis to give them those baselines and try to figure out through this community engagement how things would change over time, how many more improvements would occur. So the roles that we had in this as a consultant was to help them develop a protocol, which is a fancy word for saying a methods document, but that's what greenhouse gas people like to call it, a protocol for how we would do those whole dairy farm assessments. So you're seeing the front page of that. That was one of our things we had to do. But then the other thing, Houston Engineering's role on this was every time Farmers for Sustainable Food went out and collected the data from the farm, it was our responsibility to do the quantification of what the footprint outcome was on the farm from the way they were operating. So really taking everything from crop production in the field all the way to the milk leaving the farm gate and trying to understand how's that impacting greenhouse gas emissions and how's that impacting water quality. Those were the two main buckets of things we were looking at. And then through that, support aggregating the data. One of the things, if you get involved in this and you're enrolling farms in the private sector, they're not really in a hurry to put their individual farm reports up on websites. But if we get enough farms, we can aggregate the results and have a bit of a public-facing story to tell. So at the time, the way we went through this is we had to use a range of models and tools to represent a whole dairy farm. So it's acronym alphabet soup up on the screen here in terms of the tools we had to use. If you get into greenhouse gas modeling and all, you probably recognize some of these. Comet Planner is a very simple tool that gives you just a reduction in greenhouse gases. It's operated by the USDA, and it gives you a reduction based upon acres of conservation on a field. We used that because the USDA told us we had to as part of their program. But the components that we were really looking at to represent the whole farm from a greenhouse gas perspective were manure DNDC and DNDC. These are both public versions of the tool that we adapted for our use. We use two different forms of DNDC because DNDC is much better at representing the dairy operation itself, whereas DNDC, without the manure on the front of it, is much better on the crop production side of the equation in terms of, it's our professional opinion anyway. And then neither of these is very good at representing energy use on the farm. So we used Comet Energy as a model to represent that. And then PLET is an EPA tool that can perform the water quality calculations for us based upon the conservation on those farms. So that's the system of things we pulled together to do this. Just to tell you how much variation there is in consulting in our industry, we finished that protocol 2 years ago. We did get to apply this on over 100 farms. As of February, this project was one of the projects that was suspended by USDA. So they're currently in discussions with USDA as to whether or not they're going to get reapproved to continue with this project through what's now called Advancing Markets for Producers, or AMP. So it's no longer going to be called Climate Smart. And the dairy industries released their own model. So if we do start up again, we're going to throw all this away and do something different. So it's kind of the way it goes in consulting. But we did get very good feedback on our approach. And just giving you a sense, I talked a lot about the individual results. Similar to my fuel producers sheet, this is all made up stuff. So the farm name is sample, sample, sample. I went through and took a real report on a farm and I twisted some of the numbers around. So I'm not showing you an individual's farm data. So if you snap a picture and are like checking my math at some point, it's going to be off a little bit because I manipulated the numbers just so I wasn't sharing any sensitive information. But this gives you a sample of the level of granularity where we're getting into on these individual farms. I'm focused only on the greenhouse gas fluxes. And one of the things that was really phenomenal on the farms we worked with, and some of these are really big dairy farms, like, a few of them were 10,000 plus milking cows on the farm in a year. So they're pretty big, sophisticated operations. This number here is the one I'm going to call out without going through each one individually. So this is the carbon intensity of milk production, these two numbers. And if you can't see it in the back, I got a 0.35 here with an industry average range from the literature of a 0.8 to a 1.2. Some of the more recent work that has been published on this would suggest that that gets dialed in right around 1. And the units of that are kilograms of fat protein corrected milk per kilogram of CO2 equivalency. And that work actually, the newest work is actually authored out of researchers from the University of Minnesota. So the university is engaged in this stuff pretty heavily in some spaces. What's pretty phenomenal here though, right, is just how far below the industry average this operating dairy is. And I manipulated the numbers a little bit, but they are indicative of a lot of the farms we had the chance to work with. So number of milking cows, several thousand, that's a big farm. And an efficiency relative to your emissions that's well above industry standards. And we saw a lot of farms come through the door in this project that were below that industry average just in their baseline conditions. So that was pretty exciting to us. The other thing, and I didn't include a statistic in here, if you're sitting in the room, this just looks like a huge page of text with maybe a ton of meeting, where you're sitting today. But at the end of the first 2 years, when we had gotten a lot of these reports out, I think we were on almost 80 farms or so had received the reports. The client conducted a survey and they had a 80% response rate on the survey of these farms. So to me right away, that's a win. When we do surveys in industry, if you get like a 10 to 15% response rate, you're like excited, people responded to you. So when the members of these farms that enrolled, we got that response rate, we were pretty excited about that. And of the responding farms, over 70% had a very positive impression of the information they received and how that might impact their operation on their farm. So again, there's, take the exact numbers with a grain of salt. You saw when we ran the various models on soybean production, the numbers are all over the place. I think we're generally within the right range when we're doing this assessment. But the thing that was really exciting to me when we got done with this before it got suspended was, the farms that are getting this data actually really like it, and they think it's going to have an impact on how they're running their operations. Let's see, I'm getting short on time, so I'm going to skip this one and jump to my next section. We can come back. So I spent a lot of time focused on greenhouse gases, the bulk of my presentation window. I'm going to shift gears to water here now. I did this intentionally too. My group, as I mentioned, I don't have any formal educational background in greenhouse gas emissions. The group that I'm a part of at Houston Engineering, I would say 95% of our team members, their professional background is in water science of some form or another. So, but again, part of consulting, when we have clients that come to us with problems and trust us to try to solve them, we dive in and try to figure it out. And a lot of my last 5 years in consulting been very focused, heavily focused on greenhouse gas outcomes. But we do still do a lot of work with water inside my group and across our firm too. But inside the group we're focused on here today, I'm just going to highlight 2 studies we've done recently, some of which will be familiar to topics that have been presented in seminars within this department in the past. The first one is drainage and water in Minnesota. So if you follow this topic at all, and I haven't seen as much in the news on this recently, but when I was on staff and a student here, that's definitely in the news a lot and discussed a lot, is how does tiling impact environmental outcomes in the state of Minnesota? And this was with Minnesota Soybean Research and Promotion Council again. If you work in the private industry, one of the things you'll see is when you get engaged in local application of state studies and even published work, a lot of the discourse does lean heavily towards the idea that tile drainage has created some very serious environmental problems in our state. And Minnesota Soybean Research and Promotion Council came to us and asked the question, we know there are some studies that would suggest weather and climate are a bigger driver of those impacts than tile drainage, so the impacts you see in the environment. Could you do a summary, Drew, of what different studies concluded without offering any opinion as to whether or not those studies are correct or not? And so it was an applied thing connected to water that we're like, yeah, I think we could get involved and help out with that. And so we took on a fairly quick project that was really just a literature review of peer-reviewed research to summarize the conclusions of peer-reviewed work that are investigating changes in stream flow and whether or not those changes in stream flow are connected to climate or anthropogenic changes. And we were boxing anthropogenic changes as things like changes in drainage, changes in land use, land cover. And again, this was actually, so while I was here at the department, I was involved in some of the peer review research that addressed this topic. So one of the hardest parts for me in consulting and doing this was that part where I do not get to offer any opinion as to which research was correct or not. As a matter of fact, I might have had lunch with a former faculty member of the department on this report, where one of the hardest parts of our discussion was how does this get done without offering opinions? But this was the punchline anyway, and we summarize this at 2 levels. Was the research focused on surface waters in Minnesota, or was the research focused on Minnesota and beyond in terms of its look at surface waters? Because just from my own experience, I've been in other states where this topic isn't even really being discussed. But within Minnesota and Iowa in particular, I'd say a lot of people focused on this topic, at least historically. And I'm only showing a snippet of the report, which is our conclusion table, where we've counted up the peer-reviewed articles, and we had the only assessment we really made. We went into their conclusion section, really didn't read their methods or anything else, and said, did they conclude precipitation was a driver of changes in flows, or anthropogenic changes were a driver of changes in flows? And some of them had check marks in multiple boxes. And this is where we came up with. So, I mean, if you were to draw a conclusion from this table, I would suggest that in terms of the peer-reviewed research, maybe the verdict's out. There's a lot of different ideas as to what's going on here. But we didn't draw those conclusions. And when we finished this, we stuck all of our citations in, and then we took our Excel table where we generated this and we stuck it in as an appendix. So if people don't agree with the way we characterize the research project, they can go and change it, update the table. And a more modern one, and you guys might have heard about this, they had a little bit of an issue with Rapidan Dam recently. It failed, or at least partially failed. I'm guessing most people in the room heard something about this in the news at one point. Lots of rain within the basin that feeds this area, way too much water cranking through here. And instead of going over the designed engineered spillways to get around the dam, it cut its own course around. And you're seeing images from a news article on the right side of the screen, what that kind of looked like. So we got an ask, Houston Engineering, could you go out and quantify how many tons of sediment and phosphorus this might have dumped into the river in that one event? And again, quite a bit of established peer review research on techniques on how you might do this. We weren't asked to do anything novel in terms of that. We were just asked, hey, can you go use those techniques, do a quick estimate on this? You see the numbers here in terms of punchlines already. So over 400,000 metric tons of sediment that was dumped into this river. And the average annual load downstream of Rapidan Dam on the Blue Earth River, so this is for a whole season, not just one event, is 245,000 metric tons of sediment per year. So maybe not overly surprising when you look at this picture that this one event probably had a pretty big impact in terms of the material being pushed down this river system. Just a quick caveat on the techniques we used and what that number means. So on the right, we took the state's airborne LiDAR. So if you're not familiar with LiDAR, it's some type of craft flies over the Earth's surface, shoots lasers down and gives you elevation of the Earth's surface. We took statewide airborne LiDAR. Our survey crew went out and flew a drone and used a drone-based LiDAR to get a modern one, and we subtracted the two. And we only looked at the places circled in red in terms of sediment contribution to the river system. So we didn't do any bathymetry of the river itself for material that was likely built up behind the dam that could have been flushed out as well too. So the numbers I showed you on the previous slide, and I'll have highlighted again on the next slide, are probably pretty conservative estimates, but this gives you a little more sense of what that means. So when you think about that failure in June of 2024 and these 427 some thousand tons of material, once again, that's probably conservative. The number is most certainly higher. That's approximately 80% of the highest yearly mass load ever recorded at the downstream monitoring station, just from that one event from the dam. So punchline there is some of these, very big events can have pretty big environmental impacts once they happen. Not too surprising, especially if you've ever watched those dam removal videos on YouTube where they blow the dam out and everything comes washing out. It's pretty phenomenal. But on the phosphorus end, I mentioned that. The phosphorus associated with those sediments, and to be clear, in our contract when we did this work, we were supposed to grab soil samples from the failure site, but it was so unstable we couldn't. So we did not send staff down into the failure area to get soil samples specific to this site. Instead, we had to rely on literature values that had been gathered from throughout the basin. So there's a plus or minus to this in terms of the bulk density, the soil characteristics, and the phosphorus attached to those sediments. But when we did the conversion using literature values from our mass of soil to phosphorus, the phosphorus accounted for about 58% of an average annual load. So one-time event, the mass of phosphorus was about 58% of a typical average annual load. So a lot of material that got pushed through. My final one, and I wanted to give time for Q&A, so I'm only going to give one of the case studies in here. I put too much material in my slides, is applied science connected to policy. So at times you'll see different policy things happen. And in the consulting world, at times organizations connected to interacting on those policies, like in St. Paul or DC, might come to a consulting group and say, hey, can you help us with the technical approach to have information to help us on this policy? Jump forward. I'm going to skip that one and do this one instead because it's a little more local and a little more of interest in my opinion. If there was just a few years ago a case proceedings in the state of Minnesota called Limbo Creek. Limbo Creek is a very small creek in Renville County, Minnesota. There was a local drainage authority who wanted to take some drainage action on this creek. In practice, what the drainage professionals do is they go to something called the DNR's Public Water Inventory map. And if it's on that map, it is considered a water of the state. It's then subject to state statute on how those waters are managed. So there's different regulatory pathways that the water needs to go through if it is on the map. Well, Limbo Creek wasn't on the map, but there was an environmental group that asserted based upon the statutory definition of public waters, it should be on the map. And the basis, and I'll get into this in a minute, is this idea in statute in Minnesota, if anything drains 2 square miles or greater of surface area, it is a water of the state. But the DNR's public waters inventory does not jive with that definition today. So the court did uphold the I don't know what the exact word is, I'm not a lawyer, the person that sued that said it should be a public water won. And so that water needed to be managed as a water of the state. So what we got asked to do is, hey, Houston Engineering, you can run these spatial assessments. How many miles of water are we talking if we go with 2 square miles as opposed to the DNR's public waters inventory map? So DNR's public water inventory map is a public data set. We pulled that out. We looked at the statutory definition. We used the transparent method for mapping waters based upon that statutory definition. And we asked the question, if the legislature doesn't empower the DNR to be in charge of what is a water of the state, what's the impact in terms of regulated miles of water within the state? And this is where we ended up. So if you go based upon the statutory definition, it would be just shy of 60,000 miles would likely be regulated. Based upon what's mapped in the DNR's water inventory, it's currently about 42,000 miles. So those are both big numbers, right? But the difference between them is still a pretty significant number in terms of increased regulated miles of waterway. It was interesting that we actually had more lakes in the public waters inventory than the statutory definition. And the biggest difference, although we haven't seen this pan out in practice yet in industry or haven't heard too many impacts, was actually the wetland acres. It was a lot. The statutory definitions for wetlands was far more expansive than what was actually in the DNR's public waters inventory. So again, really applied work connected to policy here. And I'm not going to go through the table in the bottom right because I want to give some time for Q&A, but we also broke the numbers in the upper left up by different agricultural districts in the state of Minnesota in terms of where most of those miles were at. So you see the more detailed breakdown. So again, this table is just a jurisdictional breakup of the data up in the upper left. But again, I know that was a bit of a whirlwind of different case studies. My purpose for doing that was that's kind of what consulting is like. And especially for the students of the room, wanted to give you a sense of the type of work that consultants get involved in spaces connected to soil, water, and climate. So I'll leave it at that, and we should have at least a few minutes for questions, I think.
One question about your climate change and greenhouse gas modeling efforts. So you were talking about how it took you a lot of models to get to results you like. How much accuracy do you think will be lost by the USDA giving you a model that's used for calculating carbon intensity kind of across the board?
What we see in application in many instances are broad regional or national values are used in a lot of these calculations. So I would say the uncertainty in using those values at a site-specific location is massive in a lot of instances. Now, to be clear, when we were doing the more focused work with Farmers for Sustainable Food, and I talked about the 250 some data points, the information we were using on those farms for the more intensive assessments was very granular to the farm. So we were taking their exact operational decisions for that year and fitting that into a 20-year model run that was warmed up for 20 years and then doing the assessment for that year to try to get that result a little more precise. But again, backing out to, I think, the intent of the question, Dr. Cates, when you take something like Comet Planner that at best is regionalized with broad data sets and apply it to the acres of conservation on an individual farm, you likely have massive uncertainty bounds on your estimate.
I have a related question. When you're kind of getting granular on a farm, do you get granular across the different greenhouse gases as well? Because I noticed, you know, you're showing everything in like CO2 equivalents, which is the apples to apples comparison. But when you're talking about cropland or you're talking about cows, you know, you have very different mechanisms and very different greenhouse gases of how to help those farms reduce those gases. So I was wondering, yeah, how much as a consulting firm do you dial into how to help them reduce the individual greenhouse gases and not just the CO2 equivalent?
That's a great question. So behind the scenes, and I didn't show the data and I didn't get into the exact particulars, we are generating estimates through these models for the various major carbon pools. In this instance, we were using AR4 to do the equivalency pull together. I know it's for those in the greenhouse gas space and industry, they're using AR6 now, so there's a disconnect there. Yeah. But the models we were using, several of them had hard locks and AR4 in the background for the conversion of. The second part of that question, though, how are we engaging with the farm to understand steps for improvements? What we would do when we generated those individual reports is there'd be a combination of that nonprofit team member as well as our scientists doing a one-on-one meeting with the farm and going through the report. So that was part of the project. And it was pretty phenomenal at how quickly the farms latched onto some of the operations and the connections and asked questions about why is that number that way. And when we pulled through the data and told them, well, it's because you stacked your manure in the tree row for 3 months before you spread it, and that's got a lot of emissions. They're like, oh, I should do that differently. So that, and I think actually, I put that report up and said, farmers love this. It was a great survey response. I don't think it was the report itself. It was what our nonprofit partner did to do the one-on-one meetings and walk people through. Now, the change element to your question, our project got suspended before we really got to dive into that, because built into the next phase was doing scenario planning on those reports for how they could make adjustments in the future.
And was it like non-carbon gases like the N2O?
Yeah, methane, N2O, carbon dioxide, and I'm going to miss one because I forget things. Yeah, we do the 4 main pools.
Yeah.
Yeah. Great question. And so for the online audience, if you didn't hear, is in these assessments are there, and I'm paraphrasing, tools or models that could hit more metrics created to environmental outcomes, things like maybe biodiversity or other types of outcomes that are connected to sustainability and environmental outcomes. We do see that in industry. And I'll mention one. The reason for the focus of my presentation is that is what the focus of our clients have been in the last few years. So we aren't seeing as much interest or pressure on things like biodiversity and other maybe indicators of environmental outcomes associated with food production, but they are there. One of the spaces of work that we're involved in where they do produce metrics that are supposed to be broadly representative of environmental outcomes is the field print calculator from field to market. So that is a calculator. They have something called a spider web diagram that comes out that shows you all of your various scores across, it's like 7 or 8 metrics. And they have a pretty robust stakeholder process that includes academic affiliates, nonprofit affiliates, industry representatives, and developing those metrics. We're familiar with it because we do have a technology services group that does custom software development, and we are the vendor that builds and operates that field print calculator. And there are, beyond that, there are a number of other efforts out there to do a broader quantification of environmental outcomes. There's a group even here on the University of Minnesota strongly affiliated with it. The Invest data model through the Natural Capital Project does a pretty robust job of that. So I think it's applied economics just a little south of here. Dr. Steve Pulaski is one of the leads with that. So you guys do have folks on campus here as well too that do that. We see that in industry as well too every once in a while. Bit of a side tangent, but there is a growing recognition of that in engineered projects that are supported with federal funding. So if you have federal dollars associated with a large engineering project, typically you're pressed to do a cost benefit analysis. So you need to know that the societal benefits of that project are equal to or greater than the cost of the project to get a no-brainer yes for federal funding. Sometimes you can be a little below and you can figure out ways to justify it, but reason for that background, there is more pressure within those federal funding streams to quantify and monetize environmental outcomes across a broad range of categories associated with those projects as part of that cost benefit analysis.
You got any advice for the students who may want to join consulting? Have to do with what to do?
Get involved in projects as much as you can, whether that's working with faculty on research projects. I would say in addition to your education, build experience working on things. When we have applicants come in, that's one of the first things we look for. I mean, we like to see them with a strong academic degree and a department that we trust from a university we trust. Those things all play in, but we usually get a lot of those applicants. If you're wanting to differentiate yourself, get involved in work that you can also put on your resume.
Have you got any questions of the drawing? No. So I think we're close to the 4:30. I appreciate your coming over here. And if you guys have any contacts, you want to know more information, Dr. Kessler is right here in the room. Can do it again. Let's give him a break.
पहले आप अपनी जुबान में गाना गाती थी?
हाँ जी, राजस्थानी हमारी जुबान।
वो कैसी होती?
वो मतलब
जरा बोलें।
ये करो इकट्ठे जाओ खाना के समझ आई हमारे
ऐसे थोड़ी। हम लोग उन खाना बदोश कबीलों में से हैं ना, जो कि एक जगह से दूसरी जगह अपने घर मुंतकिल करते रहते हैं। जहाँ काम मिला वहाँ पड़ाव डाल दिया। तो उनके जो गाने होते हैं, उनकी जो रस्में होती हैं, वो सारी चीजें आपके अंदर हैं, आपको याद हैं, आप करते थे।
जो मेरे माँ बाप थे वो राजस्थान के थे ना, बीकानेर, तो वहां से हम आया